class. Today what we're going to do, we're going to talk about arithmetic sequences. So an arithmetic sequence is a list of numbers that follows some rule or pattern. So it's going to be adding or subtracting or dividing or multiplying by the same amount each time we do it. So an arithmetic sequence is a specific sequence where we're adding or subtracting the same amount. So that amount that we're adding or subtracting each time, that's called the common difference. So the common difference is the number that we're adding or subtracting each time. And the letter that we're going to let represent our common difference is just a lowercase d. So lowercase d, make it look a little more like a d. So lowercase d, that's going to represent the common difference. So that's what we're adding or subtracting each time. So there's two formulas that go along with this. There's the recursive formula and the explicit formula. The recursive formula is a way to build our sequence. So we're going to start with the first term. So n is always going to represent that term number. So that's that number that's in the little subscript. So whatever number we want, that's the number that we want to get to. So we need the first term, which is going to be the recursive. And recursive, you think of the word recur, it means we're going to keep doing the same thing over and over and over. And so with the arithmetic sequence, we're going to be adding the same amount each time. And then an explicit formula, the explicit formula allows us to jump to a term that's farther on down the list. So if we wanted the 40th term in a recursive sequence, we would have to add whatever our common difference is each time over and over and over until we got to the 40th term. So we'd have to add 40 times to get to that explicit formula, to get to that 40th term. But we don't want to do that. We want to use the explicit formula to kind of shortcut that, and that'll allow us just to jump to the 40th term. So the recursive formula, first thing we're going to need for a recursive formula, you always have to have it, is that first term. So a sub 1, you're always going to have that in there. I'm just going to let it represent as an x. It's going to be some number, whatever it is, that you have to have a first term in all recursive formulas. And then what we're going to do, since this is arithmetic, we're just going to add the same amount each time. So we're going to start with the previous term. So the way that we represent the previous term is that a sub n minus 1. Anytime you hear the word sub, that means it's in that lower right-hand corner. So basically what this means is just we're going to take the previous amount. And what we're going to do with that previous amount is we're going to add the common difference, whatever it is. So if it's positive, it's going to be adding. If it's negative, it's going to be subtracting. All right, so we're just going to take the previous amount and add whatever the common difference is. Pretty easy. Then the explicit formula, we think about we're repeatedly adding, so the shortcut for that is we're going to multiply. So for this one, we're going to always start with our first term. Okay, so that's that a sub 1, that's the first term. Then we're going to add to it that repeated multiplication, so the common difference times n minus 1. So this has a little subscript n minus 1. It is not the same. So this is the common difference times the variable n minus 1, and that n represents the term number. So the n in this case is the same as the n, is the same as n. All of those are the same. So they're just the term number. So let's do a few examples. So we have these two sequences. We got negative 5, 2, 7, or 2, 9, 16, so on and so forth. So we're going to keep following that same pattern. So first thing we want to do is find the common difference. So I want to find what d is equal to in this case. So I got negative 5 to 7, 2 to 9, 9 to 16. So it looks like we're adding 7 each time. So you're just finding that pattern. That common difference for that one is going to be 7. For this one, 100, 82, 63, 44, that looks like we're subtracting a number. So that means our common difference is going to be negative. So we're going to start with a negative, and then from there to there, we look for a pattern. We're going to be subtracting 19 each time. So our common difference is negative 19. So then when I want to apply to the recursive and the explicit formula for these same patterns, we're going to do the same thing. So we are going to, here we're adding 7. So I always want to start with my a sub 1. So a sub 1 is, in this case, the first term, so that's negative 5. And then we want to write a sub n equals a sub n minus 1. So that means that previous term, that's always going to be in your recursive formula, and we're adding the common difference, so plus 7. So that is our recursive. That is, both of those things are the recursive. So then for the explicit, we got a sub n. We're going to follow that same formula. So I want to start with my a sub 1, which is -5. Then we're going to add to it the common difference, which was 7 times n minus 1. So that is our formula for those. So that's the formula for that example. Let's change colors just so you can tell the difference. And so for this one, we start with 101, go down. So I want to do the recursive. My recursive is going to start at a sub 1. That's going to equal 101. Then my a sub n will equal a sub n minus 1. And then I'm subtracting 19, so it's going to be minus 19. And then my formula, my explicit, so a sub n, my first term is 101 minus 19 times n minus 1. And so that is our recursive formula, explicit formula, and that's how we apply those formulas.